So now let's see what is in the process of getting a confidence interval for a population mean when, again, sigma is unknown. That's the key here. That's why we're using t. All right, so we would want to know that sigma is not known, the sample is random, the population is normally distributed, or n is greater than or equal to 30. All right, so we would just find the certain statistics that we need from the sample. We know our sample size. We need to get our sample mean, x bar, and our sample standard deviation. Again, these are things that we would use technology to get, but those are the formulas. Okay, we need to know our degrees of freedom, but that, again, is just one less than the sample size. And then like we did previously, we could use the t-distribution table to get our critical t-value. Then we're going to find the margin of error. Okay, a lot like before, the margin of error, the only difference between finding it like we did when we knew the population standard deviation is we're using a critical t-value instead of z, and we're using the sample standard deviation in front. So just make note of that. All right, so once we have the margin of error E, just like before, no difference in here, we're just going to take the sample mean and subtract that margin of error E, and then add that margin of error E, and that's going to give us our interval. For example, we were to randomly select 16 coffee shops, measure the temperature of the coffee, sample mean given there, sample standard deviation. It's 95% confidence interval for the population mean temperatures of the coffee sold, and assume the temperatures are approximately normally distributed. Okay, so let's go through the solution here. All right, so we are going to use the t-distribution, or expect to, because sigma is unknown. The sample is random, and the temperatures are approximately normally distributed. Okay, we do have this n of 16, which is less than 30, but again, because we know that the population is approximately normally distributed, we're okay. They gave us the mean, the sample mean of 162. They gave us the sample standard deviation of 10. They gave us the confidence level, 95% or 0.95, and the degrees of freedom, again, that's going to be n minus 1, so that's 15. Now, we're not actually using a table, we're going to use Excel. We have a degrees of freedom of 15, and again, our confidence level of 0.95 is a probability of 0.05. So let me bring up here and say equals t, the two-tailed inverse, 0.05 and 15, 2.131. So we'll go with 2.131. All right, so then the margin of error would then just be the critical t-value times s over the square root of n. So we'd have 2.131 times that 10 was given over the square root of 16. Multiply that out and you get about 5.3. Okay, so we're not done there. we now have to take that 5.3 and subtract it and add it to our x-bar to get our margin, or our interval. So we would take 162.0 and subtract 5.3, and we take 162.0 and we'd add 5.3. I think I said something else before, 5.3. So that would give us 156.7 on the lower end and 167.3 on the upper end. And so with 95% confidence, we can say the mean temperature of coffee sold is between 156.7 and 167.3 degrees. So now, let's talk about how we're deciding which distribution that we're going to use. Are we going to use the normal or the t-distribution, or can we not even do the problem using one of these distributions? So the biggest thing is, when we start, we're asking, is the population normally distributed, or is the sample size at least 30? If neither one of those is true, then we can't use either the normal distribution or the t-distribution. Okay, but if one of those two at least is true, then it's a question of whether we know the population standard deviation or not, sigma. If we do know it, we would use the standard normal, so we'd be using critical z-value, and we'd be using sigma. If we don't, then we'd be using the t-distribution. We'd be using a critical t-value, and we'd be using the sample standard deviation. That's the difference. For example, let's look to see and decide whether we can use the normal or the t or neither. You randomly select 25 newly constructed houses. The sample mean construction cost is $181,000, and the population standard deviation is $28,000. Assume construction costs are normally distributed. Should you use a normal, t, or neither in constructing a 95% confidence interval for the population mean? Okay, so here's the things that we'd be asking. Is the population normally distributed, or is n greater than or equal to 30? Well, n was only 25, but they did tell us that, yes, the population is normally distributed. Okay, so we're good. Is sigma known? Yes, because they actually did say that we knew the population standard deviation sigma. So since we know that, we would use the standard normal distribution. In other words, we'd be using z.